Welcome back to Topic 1 for Algebra 1, PEMDAS and Properties of Real Numbers. In Part 1, we're going to review what PEMDAS stands for, as well as learn about the properties of real numbers and look at some examples. So let's first review what PEMDAS, or sometimes referred to as GEMDAS, stands for. The P stands for parentheses. Now notice here how we also have a P/G, because the G, sometimes it's referred to for grouping. For instance, when we're using PEMDAS to simplify an expression, we won't always see parentheses. Sometimes we'll see brackets, or sometimes we'll see like a curly bracket. So there's a bunch of different grouping symbols that we could see. So keep in mind, if you do choose to use the PEMDAS acronym, that you're looking out for all sorts of grouping symbols. The E stands for exponents. The M stands for multiplication. D stands for division. A stands for addition. And S stands for subtraction. Now I made a note here for multiplication, division, and addition and subtraction. These are kind of tied together. So when we simplify an expression using PEMDAS, we want to simplify from left to right. Just like how you would read a sentence from left to right. However, if we're looking from left to right and we see division first, before multiplication, we want to simplify the division first and then the multiplication. Also going along, if we see subtraction first and then addition, we want to simplify the subtraction. So either way, the M and the D, we should simplify those first before we simplify the A and the S, the addition and subtraction. But sometimes we might see the acronym represented like P, E, M or D, A or S, this vertical method. And they're kind of interchangeable, the M and the D and the A and the S. So we want to simplify whichever comes first. Moving along to some properties of real numbers. So with properties of real numbers, we're really going to focus on addition and multiplication specifically, not subtraction, not division. And I'll show why in a moment. The first property is the associative property. I always think of this as I want to be associated with Taylor Swift. So I want to be grouped with her. So we're going to use a grouping symbol. So for example, for addition, we can have A plus B plus C, and that's equivalent to A plus B plus C. All I did here was just group the B and the C together in the first on the left-hand side, and then the A plus B on the right-hand side. So for example, if I wanted to use actual numbers, this is the same thing as 3 plus 4 plus 5 is the same thing as 3 plus 4 plus 5. And we can think about that with PEMDAS. We would simplify in our parentheses first. 4 plus 5 gives us 9. Then add that 3, we get 12. And on the right-hand side, we have 3 plus 4 gives us 7. 7 plus 5 also gives us 12, so it's equivalent. Now, similarly with multiplication, this is A times B times C is equivalent to A times B times C. So numerically, if we want to see that, we can write it as 2 times 3 times 4 equals 2 times 3 times 4. So again, if we look in our parentheses first, 3 times 4 on the left-hand side gives us 12. 2 times 12 is 24. On the right-hand side, we have 2 times 3 gives us 6. 6 times 4 is also 24. So that works there. Our next property is the commutative property. So the commutative property is all about flipping the order and it will still stay balanced. It will still stay the same. For example, A plus B equals B plus A. In other words, we can have 3 plus 6 is the same thing as 6 plus 3. We'll still get 9 either way. For multiplication, this is the same thing as A times B equals B times A. For instance, 4 times 5 is the same thing as 5 times 4, as you probably found out in like your elementary school class. Our next property is the identity property. So the identity property, when you think about your identity, you think about yourself. We want to return to ourselves or return to the same initial value that we see as our final answer. So for example, for addition, we have A plus 0 equals A. By adding 0, we are not changing the value. We're not changing the identity of our initial number here. Here we have A. So if we think about this numerically, this is like 8 plus 0 equals 8. We didn't change the overall value of this expression. We just added 0 to it. It did not change the value of 8 whatsoever. If we think about multiplication, what can we multiply by a number so that we get the same number as our output? We can have A times 1 gives us A. If we multiply a number by 1, it just gives us itself again. So we could have 7 times 1 gives us 7. Moving along to the inverse property. Now inverse, sometimes people usually think of opposites, and that's partially correct. Opposites are correct when we're referring to the additive inverse property. So for example, if we look at a number line and we're at some space A on our number line, the inverse of A is the opposite of it. So here we want to think about the opposite sign. Negative A. So if we take A and we add negative A to it, we will end up getting 0. This negative A here is the opposite. Numerically, if we want to think about that, let's say we have 5 and we want to add the inverse of that. The opposite of positive 5 is negative 5. When we combine them together, we get 0. Now, when we think about multiplication, it's a little bit different. We're not thinking about the opposite because we're not changing the operation in front of the number. Here, let's say we have A. We want to multiply A by something so that we get 1. Now this is really A over 1. What we can multiply A by is not its opposite, but its reciprocal. So 1 over A. If we simplify this and multiply across, we would get A divided by A, or just 1. So numerically, we can use the example 2 times 1/2 equals 1. This is really 2 over 1. So again, looking back to the inverse property, for addition, we're dealing with the opposite in terms of the operation, the sign, whereas with multiplication, we're dealing with a fraction here. We're dealing with the reciprocal. Okay, now on to the distributive property. Now for the distributive property, there isn't really a distinction between addition and multiplication because it kind of combines both. So hence why I don't have a separation for the two columns. The distributive property is defined as A times B plus C is the same thing as A times B plus A times C. So we're taking this A and we're distributing it to the entire quantity that's in our parentheses here. Now, I do want to make a note that sometimes we might see the distributive property, but maybe the number that we're distributing doesn't come first, but actually comes second. So for example, what if we have B plus C times A? Now this will actually get us the exact same answer. Why? Because this is actually the commutative property of multiplication. We have our two values here, and we just flip the order. Remember, 4 times 5 is the same thing as 5 times 4. So if we were to distribute this way, we would get A times B plus A times C. It's just rewritten initially a little bit different. Okay, let's see a numerical example. Let's say we have 5 times 4 plus 6. This is the same thing as 5 times 4 plus 5 times 6. Okay, moving on to the multiplicative property of 0. The multiplicative property of 0 basically says that if we have a value A and we multiply it by 0, so if we have any number and we multiply it by 0, our final answer is going to be 0. So if we have 7 times 0, that's going to give us 0. 10,000 times 0 also equals 0. Last but not least, we have cross products, the cross product property. Now, sometimes people might see this referred to as cross multiply. What this property states is if we have A divided by B equals C divided by D, then that is equivalent to A times D equaling B times C. So the numerator of one fraction times the denominator of the other equals the denominator of the first fraction times the numerator of the other. Now notice we can only cross multiply when we have an equal sign separating them. I'm going to say that again. We can only cross multiply when we have an equal sign separating them. Sometimes students are tempted to cross multiply when really we're just straight multiplying two fractions, but we can only cross multiply when we have an equal sign separating our two fractions, no other operation. And that was part 1 for topic 1 for Algebra 1, PEMDAS and properties of real numbers. Thank you for watching.